Bicon Girder is a pre-stressed concrete girder system that utilizes a common tendon and the interaction between the upper steel bar of the girder and the tendon, which is applied in the existing PSC post-tension girder. Bicon Girder has a pair of upper steel bars arranged parallel to each other, and a parabolic-shaped tendon that starts at the same position as the steel bar at the end of the girder and gradually moves towards the lower part of the girder as it reaches the center. These components are combined by the integral pre-stressing system at the end of the girder. When pre-stressing is introduced, the tension in the tendon is pulled by the tension jack, and compression force is introduced to the steel bars combined to the connectors. As a result, the concrete girder is subjected only to a large bending moment due to the placement of the steel bars and tendons, and moment pre-stress is introduced into the girder by this bending moment. In the traditional PSC girders, compressive stress and bending stress are applied to the concrete girder at the same time when pre-stressed, but in the concrete girder with an integrated tension system, the steel bar at the top of the concrete girder receives the compressive stress, and only the bending stress resisting the external force is applied to the girder. In addition, due to the increase in external forces caused by the span length gets longer, traditional PSC girders require a bulb T cross-sectional shape with a wider top flange than the bottom flange to resist the large compressive force on the top flange or to increase the girder height. However, the Bicon Girder minimizes the stress on the top of the girder by the integral pre-stressing system, allowing for an invert T cross-sectional shape with a narrower top flange than the bottom flange. This shape improves the safety against the risk of overturning while transport and erection of the girder by securing a low overall height, and also increases the section resistance capacity by generating an effect in which the moment of inertia becomes larger after the slab is composite. Bicon girders are typically produced on-site through a process that is similar to the production process of typical PSC girders. However, there is an additional process of installing an integral pre-stressing system and introducing pre-stress. The tensioning method of the integral pre-stressing system is the same as that of traditional PSC girders, which involves introducing pre-stress through tension jacks, so it is easy to produce girders without difficulty. To verify the structural safety of the Bicon Girder, structural analysis and performance test of connector of integral pre-stressing system of Bicon Girder were conducted. Static and dynamic loading test on 20 meters length Bicon Girder mock-up were conducted, as well as 2 each of 30 meters length Bicon girders with railway track conducted static and dynamic loading tests. The technical safety of the Bicon Girder system was confirmed by conducting field loading tests with the completion of the Wiguam-1 bridge, which is the first bridge in South Korea to apply the Bicon Girder. Starting with the completion of the Wiguam-1 bridge in 2009, Bicon Girder bridges have proven their structural and construction safety by being constructed in over 110 locations including road bridges, railway bridges, and eco-bridges in South Korea.